Hi, in this video we'll be going through hands-on 4, setting up the structure part 3, and in this hands-on we'll be specifically concerned with the transport sector and configuring the end-use categories. Now, let us move on to define the structure of the transport sector. We must first specify the fuels we want to model. To access the fuel types, we need to go onto fuel types definition in the transport tab. So we come over here, we go into general information, we go onto transport, and we click on fuel types definition. We can add or delete fuels using the respective buttons from this menu. Each fuel specified needs to be associated with a fuel type using the drop-down menu. The MAED methodology groups fuel cells into 3 fuel types: electricity, steam coal, and motor fuel. So if we click over here, we can see that they're grouped into 3 types. In order to move on this hands-on, we need to scroll down over here and we need to ensure that the fuel types that we have defined matches the ones that are on this picture. So if we go back, the first one is electricity with the fuel type being electricity, second one steam coal with the fuel type being steam coal, third one is diesel with the fuel type being motor fuel, fourth is gasoline with motor fuel, fifth jet fuel with motor fuel. Then on the list that we had, there was no LPG, so we're going to get rid of this. Furthermore, there was no CNG either, so we're going to get rid of this as well. And the last fuel type that we have is alcohol, and its fuel, the last fuel that we have is alcohol, and its fuel type is motor fuel. So now we're going to click on save in order to save this. The next step is to define the transport modes. The transport modes can be accessed using the transport tab in the sectors and clients block in the general information page. So we go into general information and we click on transport, and then we can see over here the different transport modes that are available. Each transport mode can be associated with 3 transport subsectors: freight, passenger, and freight, passenger inner city, and passenger urban. So here's freight, passenger inner city, and passenger urban. With the buttons add or delete, the user can create or delete transport modes, and with the checkboxes, the user decides in which subsectors the transport modes defined belongs to. For example, long distance trunks belong to the freight subsector. Each transport mode can be associated with any of the subsectors but must be associated with at least one subsector. So in order for the model to take this into account, at least one subsector has to be associated. We can associate a transport mode with the subsector by selecting the fuel type used for that subsector for that transport mode. This is done using the drop-down menu. So here are the fuel types, and then by selecting one of these we associate a subsector. So let's say local truck, diesel. In this case, on the freight we've selected diesel, and the passenger inner city we've not selected anything, and the passenger urban we've not selected anything. Therefore, this is going to be associated with only freight. Finally, we must tell the program which transport modes are cars or airplanes. We must also tell the program if the transport mode for inner city passengers is considered to be public or not. This can be done using the checkboxes, so these ones. This is for public passenger inner city. By ticking it, it implies that this is public transport. And over here we can select car or airplane. There's no limit to the number of modes that you want to use. Now, the hands-on instructs us, if we go further down to it, that we need to ensure that this depiction is also represented in the MAED model. So in this case, we need to go through technology one by one and ensure that they're the same. So local truck diesel defined under freight, and there's nothing selected for it. Long distance trunk diesel, again defined under freight with the fuel being diesel, nothing else selected for it. Train diesel, Here we're selected under freight and passenger inner city, and also we've ticked the box of public passenger inner city. Train electric, here we've defined it under freight using electricity, and passenger inner city. The box has been ticked as well. In the picture that's shown in the hands-on, train steam is not defined, so what we're going to do is we're going to get rid of it. The next one is barge, which is defined under freight using diesel, and nothing else is selected for it. Pipeline diesel, this is defined under freight using diesel, and nothing else is selected for it. Pipeline electric, defined under electricity, nothing else selected for it. Then we have car gasoline. So we've got this is considered as passenger inner city. It is not a public transport, so nothing is ticked, and the type is car. It is also a urban passenger, so that's why there is gasoline selected underneath in order for the model to be able to comprehend this. Car diesel stands in the same situation. Car alcohol is not defined in the list that there is present on the hands-on, so we're going to get rid of this. Bus large diesel is defined under passenger inner city by using diesel, and the public passenger inner city box is ticked. It is also defined under passenger urban. Bus small diesel is in the exact same category. Bus CNG is not defined in the hands-on, so we're going to get rid of it. Metro electric is defined under passenger urban, and electricity is selected for it. Tramway electric, again defined in the passenger urban, electricity selected for it. Trolleybus defined under passenger urban, electricity selected for it. And then for airplane, it is defined under passenger inner city, and it's ticked as public passenger inner city, with the airplane tick also being in place. Since we've now replicated the hands-on list to the one available over here, we're going to click save, and this has been saved successfully. The final step in defining the structure of the model is the configuration of end-use categories. We must remember that in MAED there are 3 end-use categories: motive power, thermal uses, and specific uses of electricity. We can define which categories of end uses are present in each subsector. This can be done by using the checkboxes. What we're going to do is we're going to focus on farming under agriculture. So over here we can see that specific electricity use, thermal use, and motive power have all been checked. So let us confirm by looking at this usage tables of the 3 end-use categories. Let us first look at energy intensities of motive power. So what we're going to do is we're going to go into energy intensities, and we're going to click on industry, and over here in electromotive power we can see farming being present over there. Then if we're going to confirm the electricity use, we're going to click over here, and we can see that farming is present over here. And lastly, we want to confirm thermal use, so we're going to click over here, and we can see that farming is present over here. So let us consider a scenario where the specific uses of electricity and thermal uses are not present in the farming subsector. To model this, what we do is we come back to general info, we go into agriculture, we unselect specific electricity use and thermal use, and we click on save. Once this has been saved, what we need to do now is go back and confirm and see whether this is in fact the case. So if we come over here, in electromotive, we can see that farming is present. In electricity use, it is no longer present over here. And in thermal use, it is no longer present over here. In the manufacturing sector, which is part of the industry sector, thermal uses is divided into 3 temperature ranges: high temperature, medium temperature, and low temperature. So if we come over here and we go into manufacturing, we can see this over here. So there's temperature medium, there's temperature low, there's temperature high. When modeling thermal use of subsectors in the manufacturing sector, we also need to select which temperature ranges of the thermal use to model for each subsectors. In this case study, all three temperature ranges have been chosen for basic materials. The model structure is now configured, and all input data tables and output tables correspond to the defined structure. The model is ready to be loaded with input data. Thank you very much for watching this video. I hope this was helpful.